Graphene batteries have been creating a lot of excitement lately, and after digging into the latest developments, I was surprised by how quickly things are moving around the world. Several countries and companies are now racing to bring different types of graphene-based batteries to market, each with its own strengths and ideal uses. In this updated video, I'll walk through the main types of graphene batteries, where they're being developed, who the major players are, and what kinds of devices or industries each one is being built for. The goal is to keep this clear and easy to follow, while giving a fresh look at where the technology actually stands today. Even though there are many technical details behind graphene batteries, the big picture is pretty simple. Graphene helps electricity move more easily through a battery and prevents heat from building up. That means faster charging, better safety, and longer life. Not every battery works the same way, but across the board, graphene tends to make batteries run cooler, last longer, and pack more energy into smaller spaces. These improvements are becoming especially important as more of our devices, and even cars, depend on better energy storage. At this time, I would like to ask you to hit the like button and subscribe. It doesn't take much effort, and it's simple to do. Plus, I really do appreciate you watching. Thanks again. Now let's get back to graphene batteries. Graphene-enhanced lithium-ion batteries are the closest thing we have to mainstream graphene technology. They're basically upgraded versions of today's lithium-ion batteries, using graphene inside the electrodes to help everything run more efficiently. In the United States, companies like Nanotech Energy are building large facilities to produce these cells. China has major graphene developers such as Guangzhou OED Technologies, Canano, and research groups at GAC. South Korea is also heavily involved, with Samsung working on its own graphene-based enhancements. These upgraded lithium-ion batteries are mainly aimed at devices that need faster charging and long-term durability, such as premium smartphones, drones, laptops, and power banks. Some automakers are experimenting with the idea of using them in future electric vehicles, although scaling the technology to full car battery packs is still a work in progress. Another exciting direction is graphene aluminum-ion batteries. These take a different approach by using aluminum instead of lithium, and they rely heavily on graphene to make the chemistry work efficiently. What makes this technology stand out is how quickly it can charge and how many times it can be cycled without degrading. Australia is leading the way here, with Graphene Manufacturing Group making big strides toward commercial versions. China has several research efforts underway, and the United States has university labs and startups testing early concepts. The first real-world use cases for aluminum-ion graphene batteries will likely show up in smaller devices where fast charging and long life really matter. Think compact electronics, wearable medical tools, smart home devices, and drones. They're also well-suited for stationary energy storage systems because they can cycle so many times. Over the long term, they may play a role in electric transportation, but the early focus is definitely on smaller devices and compact energy systems. Solid-state graphene batteries are still in the experimental phase, but they're attracting a lot of attention because of their potential. These batteries use solid electrolytes alongside graphene-enhanced electrodes, which could lead to extremely energy-dense and stable designs. Companies in Japan, South Korea, and the United States are heavily invested in this work. Toyota is exploring graphene layers to boost stability in its solid-state prototypes. LG Energy Solution is researching graphene composites for solid electrolytes, and QuantumScape is testing graphene-based interface materials in its next-generation cells. The markets that these companies are aiming for include electric vehicles, aerospace applications, advanced robotics, and high-performance laptops. The very first versions may appear in specialized electronics, but the big long-term goal is clearly the EV market, which needs safer and more powerful batteries. However, this technology is still several years away from being ready for everyday consumer products. Graphene is also being used to enhance older or alternative chemistries. In lead-acid batteries, a little bit of graphene can make them charge more efficiently and last longer, which is valuable for industries relying on backup power systems and heavy equipment. Companies in China have been integrating graphene into large-scale lead-acid production for uses like industrial machinery and large energy backup systems. In the United States, some companies and labs have contributed research that helps push these improvements forward. Lithium-sulfur batteries are another area where graphene plays a stabilizing role. The sulfur component in these batteries can degrade quickly on its own, but graphene helps keep it stable. This type of battery is especially interesting for aviation, drones, and defense technologies, where extremely lightweight batteries make a huge difference. Although development has shifted across different research groups, the potential of graphene-enhanced lithium-sulfur cells remains strong. Around the world, several regions are emerging as leaders in graphene battery development. In the United States, new large-scale production facilities, such as the ones being built in Nevada, are gearing up to supply high-quality graphene for advanced consumer electronics and next-generation energy storage. China remains the biggest overall manufacturer of graphene materials, supplying everything from powders to advanced composites for electronics, transportation, and industrial applications. Australia has become a major hub for aluminium-ion graphene technology, led by Graphene Manufacturing Group's aggressive development roadmap. Meanwhile, Japan and South Korea are heavily focused on solid-state graphene research, aiming to push the boundaries of electric vehicle and robotics battery design. Graphene-enhanced lithium-ion batteries are already being used in a small number of high-performance consumer devices today. Aluminium-ion graphene batteries are expected to reach early commercial markets around 2026 and 2027, with smaller electronics likely seeing them first. Solid-state graphene batteries are further behind and will probably appear in niche devices before moving into electric vehicles sometime near the end of the decade or the early 2030s. Some graphene-enhanced lead-acid and lithium-sulfur batteries are already showing up in industrial and research-focused environments. Right now, the biggest barrier to widespread use is cost. High-performance graphene suitable for battery electrodes can be expensive, often reaching hundreds of dollars per kilogram. Industrial-grade graphene is much cheaper, but it doesn't always perform well enough for advanced battery applications. As manufacturing expands and companies learn how to produce graphene more efficiently, prices should gradually drop. Until then, graphene batteries will probably remain a premium option in the markets where performance matters most. Graphene batteries are moving from the lab into real-world products faster than many people expected. Several countries, including the United States, China, Australia, Japan, and South Korea, are taking the lead, each focusing on different types of graphene battery technologies. Graphene-enhanced lithium-ion cells are already in limited use, aluminum-ion versions are approaching commercial launch, and solid-state graphene batteries represent a powerful long-term breakthrough. Although costs still need to come down, the momentum behind graphene battery development is strong. We should start seeing more real products using this technology throughout the second half of the 2020s and beyond. So, what do you think? Leave me a comment, then check out some of my other videos. Don't forget to hit the like button and subscribe. Thanks again for watching, and we'll see you at the next one.